Awesome. Welcome to Radiant Sky Solar channel. I'm super excited to have you here. Welcome to today's video. So in this video, we are going to be learning about solar inverters. Okay, what do you need to know about the solar inverter? You need to know what solar inverter is all about, its role in solar system. You need to know the different types of solar inverters and also how you can read solar inverter capacity. That is what we are going to be discussing in this video. Okay, so my name is still Engineer Chuksima. Welcome to the channel. So if you are new to this channel, make sure you are subscribing to the channel, turn on notification, because we are updating content on regular basis where we are going to be teaching you in and out of solar energy for electricity. Okay, we are going to be talking about the concept, we are going to be talking about practical installation steps and processes, and also reviewing products, and also sharing with you tips that help you navigate the solar renewable energy world easily. Okay, so let's get into today's video where we are going to be learning about solar inverter. All right, so let's start with what is a solar inverter. Now, what you need to know about solar inverter is that they are the devices in the solar system that convert the direct current that solar panel that the photovoltaic system produces. They convert it to alternating current, AC current. So solar inverters convert DC current to alternating current, direct current to AC current, which is mostly used in household appliances today. Okay, like your fridge, television, most of them comes in alternating current, which is AC. Even our grid, your normal grid utilities, your NEPA light and all that, they all come in form of alternating current. So to make the energy that the solar panel produce effective or useful to the home use, okay, inverter is used to convert the current to the suitable current, which is AC current. That is actually the role of inverter in the solar system. Okay, so in nutshell, the work of inverter is to convert DC current to AC current. Okay, it also regulates the voltage and power flow. This also keeps your appliances, okay, very safe. For example, if let's say there is an intensity of sun, you are using a DC current, there is an intensity of sun and the solar panel produces high voltage or a lot of voltage, okay, inverter will step it down, manage it very well, and give out the appropriate voltage or current that is needed to power devices. So that is what the inverter does. Okay, it also monitor performance. Okay, so some inverter can show you that, okay, today look at the amount of energy you have used, or look at the amount of energy your solar panel have generated and all that. All those things are also very, very useful to get to know how effective your solar system is working. Okay, inverter also can work the functions of connecting grid and batteries. Okay, depending on your setup. Okay, there's solar system that can generate current, they can generate power and send back to grid. Grid is like your normal NEPA or utility grid where that gives you electricity on daily basis. So inverter systems, the inverter system that generate power that can also send back to grid. Okay, inverter system also can connect the power from battery and supply to your house. So these are their function, not only converting direct current from the sun, they can also connect from battery and power a home, convert the DC current that comes from battery. Also, you know, solar batteries comes in DC, direct current. So inverter also can convert the DC current that comes from batteries and also convert it to AC current, which is suitable to use for household. Okay, like I also said here, inverter also can convert the direct current that comes from solar panel and send it back to your national grid, whereby it can be now used to supply to other household. So these are the functions of solar inverters. Okay, so to really explain this in a diagram, this is actually how it all works. So let's say this is your inverter. When the solar panel receives the energy, it sends it to the inverter. The inverter can convert it to the appropriate current, which is AC current. It can send it to your meter, okay, your net meter from your utility grid or whatever. In some cases, okay, it sends it direct to your home use. Okay, so in advanced situations and all that, here in Nigeria and all that, you barely see solar users generating current that they send back to grid. No, everybody generates energy that they use at home, or they use it to charge their batteries, which they can use after on. But in a nutshell, this is actually the work of solar inverters, converting the current or the power that they generate from the solar panel, sending it to your grid, okay, and also your home. In some places, this will reduce your electricity bills, okay, because you are also generating current. So when you have enough sun on during the day, you can generate enough current that you send to grid and also you use at your home. Okay, so when there is darkness or during the cloudy weather and all that, you see that your prepaid meter will start supplying. Now instead of charging from your own money, it can actually start supplying you the amount you have generated that you send back to grid. So these are just systems of how solar system work. This is the role of inverter in the process. Okay, so with that said, let's look at the different types of inverters. Okay, so you need to understand that with what we said about inverter and how they work, not all inverter will work the same. All inverters is going to work based on how it's built or the fixtures or the how it's being manufactured. So let's look at the main types of solar inverter. There are different types in terms of model, how they are built or how they are modernized and all that, but let's look at the main types that you might actually be coming across there when you are dealing into solar system. Okay, so we have string inverters, we have micro inverters, we have hybrid inverters, we have central inverters, we also have what is known as off-grid inverters. So let me take them one after the other to really give a little explanation about them so that you get to understand how they work. Okay, so starting with string inverters. Now string inverters, the way this kind of inverter work is that it doesn't use battery. Okay, it works directly with solar panels. So a lot of people normally ask me this, if it's possible for an inverter to work without battery. Yes, of course it is. So you have to go for a type of inverter known as string inverters. Okay, so how does this work? You connect two solar panels in series to a single central inverter. Okay, so the inverter is then connected to a house, okay, and the powered grid. So the power this inverter, when you do this connection, the power this inverter is generating can supply to the house or to your power grid, your utility grid. Okay, so the DC flows from the panel to the inverter and then is converted to AC. That is how this works. Areas with consistent sunlight and nominal shading, that is where this thing works very well. That is where you can use this kind of inverter where there is consistent sunlight. Okay, because it doesn't use battery, it only relies on the energy that the panel produces. Okay, so lower cost per watt because you are not going to be using batteries and all that. It's a direct production from solar panel to inverter. Okay, even the cost of implementing it is going to be low. Okay, so one of the disadvantages of this is that if one of the panel underperforms due to shade or dirty, the entire strings will output will drop. Okay, so that's why it says that it's very effective in the areas where there is consistent sunlight and there is no shading. So that is how string inverter works. So in a practical view, this is how string inverters works. So you have series of inverter means you connect plus and minus, plus and minus, plus and minus, plus and minus. In large way, you direct it to the inverter. So the inverter will convert the DC current that this panel produces and send to home for use. So that is how string inverter works. You see here, there is no presence of battery or any backup system. Okay, so these are the use cases of string inverter. So you see how it works. You see here, there is no presence of batteries here. Okay, so with that said, let's look at another types of inverter, which is micro inverter. Now this one works different. So micro inverter works different, just like a small component that is connected directly to the panel. So how this one works is that each of solar panel has its own inverter attached to it. Okay, so this micro inverter will convert the DC current that this solar panel produces to AC current instantly at the rooftop or wherever is mounted. Okay, so there is nothing like bringing all the current of the panel to one place where it can now be connected to inverter or charge control or whatever. No, each of these smaller inverters are attached to the panels. So from there on, it generates current that can be used. Okay, so the AC power is then sent to the house and the grid. The same thing the way other inverter, you can send the current, alternating current that this inverter produces, you can send it to your house for use, or you can send it to your power grid. Okay, so residential systems with shading issues or multi-roof angles can use this type of system, because since each inverter is attached to one panel, so once you have multiple of them, okay, even though one panel is shaded, the other micro inverters will also be working on other panels. So that is why it's more good where there is shading issues. Okay, so it's also slightly more complex to install and maintain. Imagine having to run micro-inverter in 20 panels. So it's going to also be very technical or complex when it comes to installations. But basically, micro-inverters are small inverters that are attached to solar panel directly, and they produce AC. They convert DC and AC current at from each of the solar panels and supply for home use. Okay, so with this let's look at another types of inverter, which is hybrid inverter. So one thing I want you to know that is that hybrid inverters can come in transformer base. Transformer base is more like a heavy duty transformer. So I'm using a brand here to show an illustration. This doesn't connote everything. This is just an example of a company producing a hybrid inverter that is in transformer base and non-transformer base. So this one is transformerless but very powerful. This also is transformer, heavy duty inverter system. So how does hybrid inverter work? So they combine solar inverter with battery inverting. For example, this inverter, single inverter, it has the power to convert direct current from solar panel to AC current that can be used for home or grid settings. Okay, they also have the power to convert your battery current to alternating current, which can be used for home. That's what it means by converting solar, okay, combining solar inverting and also with battery inverter. Okay. They have these two fixtures, be able to convert current from battery and also solar panels. So this kind of inverter also can store excess solar power for battery use or for later use. Okay, also this type of inverter are also used in off-grid or grid tie, okay, with backup system. Now off-grid means in a situation whereby you are not using NEPA to charge your battery or power your solar system. Now grid tie means that you can also combine solar power or and also your grid, like your NEPA, your electricity from national grid. You can also combine them in your solar system. So what is telling you that this type of inverter enable not only solar. You don't, working with this type of inverter, you don't need charge controller, you don't need any external device to charge your battery or power your home. This inverter will do the work of powering your home direct from solar panel. They will do the work of, okay, converting the connecting to your solar battery, DC battery, to power your home. If you have battery, they can also work as charging your battery. Okay, not just powering your home, they can also charge your battery. We also, this kind of inverter also have the power. You can use NEPA, you can connect your utility grid to your inverter. When there is no sun, when there is shade and all that, the utility grid will charge your battery and also power your home. Okay, so this is how hybrid inverter works. So they are multifunctional. Okay, they have the power to charge battery, they have the power to convert DC current to AC current, and they also have the power to charge your battery with a grid. Okay, so that is how hybrid inverter works. They can come in different brands, in different size, in different capacity, but just understand the features or how it all works. Okay, so that is it on hybrid inverters. So there is another kind of inverter that I would like to introduce to you. It's called central inverter. This is a very big kind of inverter. Okay, so a central inverter is like a large and powerful device used in utility scale solar farm to convert the combined DC power from many solar panel strings into usable AC electricity for the grid. Okay, so this one is used in terms of powering large scale solar usage. Okay, in terms of solar farming, or in terms of factory setting usage of solar system. So if you look at the size and the configurations that is needed to make this kind of system possible, you see that is majorly not something individual project. This is mostly a massive project in a situation whereby you are creating a solar farm to power a community, to power a village, to power big industries and all that. Okay, so what you need to know about the central inverter is that it's used in large commercial or industrial solar plants. Also, it's one big inverter that handles all the power for many solar panels. Okay, that is how it's built. So it's also very powerful. Like I said, not something you find commonly used for one building or so. So it has to be a way of whereby they are setting up a solar farm to power big capacity or big large community and all that. So this is actually an example of central inverter. Okay, So we have another kind of inverter also known as off-grid inverters. So what you need to know about off-grid inverters: an off-grid inverter will convert DC current from source like solar panel into alternating current, okay, which is necessary for running most of home appliances and electronics. Okay. Now, off-grid inverter can have or share similar look or features with hybrid inverters, of which all depending on how they are built. But when you hear inverter being tagged an off-grid inverter, okay, when building the inverter, they have it in mind that it's not going to work with NEPA. Okay, there is not going to be presence of NEPA, using NEPA to charge or power the inverter or charge batteries and all that. It's strictly built for off-grid. Off-grid means that it only relies on solar panel to power a home or to charge a battery. That is the features of an off-grid inverter. So you can also have an hybrid inverter have the same similar features. But off-grid inverter is built with just solar panel. Solar panel does everything, and with that is mostly used in remote areas where there is no electricity. Maybe the national grid have not gotten to that place and all that. So there is no room for electricity or grid charging the system, and so it's going to totally depend on the solar power that the sun generates. Okay, so it's built for remote areas, no presence of electricity charging or input to it. Okay, so it's usually paired with battery for backup during the low sun time, or during the cloudy weather, or during the dark time. Okay, so these are things you need to note about an off-grid inverter. Okay, so with this said, let's look at other types of inverters. So with all these kind of inverters I've mentioned, I want to also let you know that there are other types, specialized types of inverter. So it depends. The major work of solar inverter is to convert DC current to AC current. Okay, so a lot of other features can be built into that, upon that. Okay, not outside that. So other features can be built upon that. That ability to convert DC current to AC current. When it comes to that, you will now discover that you have other types of inverter that works differently or come in different ways. So to bring that to your notice, so you can have an inverter now, they will tell you that it's grid tie inverter. So when you hear grid tie inverter, it's simply a feature in an inverter that can convert DC current to AC current, and also be able to send it back to your grid, to send back to the national grid. Okay, in that by reducing their cost of electricity and all that. So this type of inverter are special inverter. Currently you don't have them common here in Nigeria, but there is a type of inverter that can be able to transmit the energy generated from the sun. It can transmit, supply your home, then any extra energy generated can be transmitted to the national grid, saving you cost and you also being a power provider. Okay, so these are different features that are in inverter. So you can find an inverter, it can be an hybrid inverter, and it's also a grid tie. So it has that features to transmit energy to the national grid. So you can also have transformer based inverter. These are inverters that are very heavy when it comes to the size, or when it comes to the weight. Okay, because they are built with special metals, coils and all that make it an heavy duty, okay, kind of transformer. Those transformers are believed to be able to chest heavy loads and all that without issues. They are called transformer based inverter. They can come in different capacity, smaller capacity and all that. So the capacity is not the main thing. The main thing is the features of the inverter. Okay, so we also have like modifying sine wave. This is more like the operational of the inverter, how the inverter operates. So we also have pure sine wave inverter. So you can come across inverter, it can be hybrid inverter and it's going to be labeled pure sine wave. It can be off-grid inverter, is also going to be labeled modified sine wave. Depend. These are just the kind of the way the inverter is built and all that, and how it operates. Okay, so we also have single phase. Okay, just like the way you power home, we power home in electrical wiring, you can power a home with one phase, two phase or three phase. So there are also inverters that come in that way, single phase. They can also come in double phase like two phase. They can also come in three phase. Okay, so these are just the features. Depending on the situations you want to use them, depending on how you want to use them, you determine the kind of inverter you go for. Okay, so basically that is it about different types of solar inverters. Okay, Now let me show you, let me walk you through basically how you can size or measure inverter capacity. Okay, so one thing you need to note is that inverter capacity is usually measured in, okay, you have volt ampere. So volt ampere, you have VA, volt ampere, that is normal setting. You have kVA, kilovolt ampere. These are the how you measure capacity of inverter. So we also have MVA, megavolt ampere. Okay, we also have TVA, teravolt ampere. These are just the capacity. So the smaller sizes of in this measurement is VA. Okay, you hear people say my inverter is 900 VA. Okay, when it gets to 1000, it starts counting in kVA. You hear people say my inverter is 1 kVA. Okay, 2 kVA, 3 kVA, 5 kVA, 10 kVA. So you hear all these measurements. So when it gets to 1000, you start measuring MVA, megavolt and all that. So this measurement, you only find it in bigger solar farming settings and all that. So there are another way you can measure rating, the rating of your inverter. So you can also call measuring inverter capacity, or you measure its rating. So another way you can measure the rating of inverter is by wattage. So you can hear watts. My inverter is 50 watts, 100 watts, 2000 watts, or whatever. So you can also hear kilowatts. So when your measurement in watts gets to 1000, it starts to be 1 kilowatt, 2 kilowatt, 3 kilowatt. So when your kilowatt gets to 1000, start measuring megawatts. So megawatts are always big projects and all that. Okay, so we also have gigawatts. This is more like, okay, this more like measuring the production in a regional settings in the country, total power production and all that, because that is when you can be able to get all these measurements. So with this measurement, all these things tells you, okay, how much load your inverter can power. Okay, so when you hear someone says that this inverter is 5 kVA, or this inverter is 1 kVA or 2 kVA, or when someone tell you that this inverter is 1000 watts or 1 kilowatt or 2 kilowatt or 3 kilowatt, all it's telling you is that is the amount of load that this inverter can carry. Okay, now for example, now if you are having, let's say you want to measure your inverter in wattage, they gave you have 1000 watts inverter. Okay, so it's just trying to tell you, let's say for example you want to use this 1000 watt inverter for your home. So all it's trying to tell you that every load you are going to put this inverter, it should not exceed 1000 watts. And how do you get to know if your load is up to 1000? It's all about load calculation. So these are things that we are going to be doing in subsequent video. I'll create time to explain this, how you do load calculation, system sizing, design and all that. But I want you to understand this thing basically. Okay, for example, if you have a inverter rated 1000 watts, it's just trying to tell you, let's say you are powering a 1-bedroom or Safecon, it's trying to tell you all the load that in that house, they should not exceed 1000 watts. If it exceeds 1000 watts, the inverter is not going to be able to power it. You need to go for a higher wattage. Okay, for example, let's say you have a house, you have 2 fans, you have 5 lighting points, you have television. Let's say your television is 100 watts, because all these electronics, they are rated in watts. Okay, your TV, your every appliances use, your AC and all that, even though they are rated in, for example, AC is rated in horsepower, but you can also convert it to wattage to know the exact amount of wattage it can consume. But let's say you have 5 fans, 4 bulbs and all that. Let's say fan is 70 watts, bulbs are 20 watts, times 4 bulbs times 20 watts times 4 is going to give you 80 watts. Plus your 2 fan is 75 watts, which is 150 watts. So you are heading about 203 watts. Let's say your television is 100 watts of 303 watts. Let's say you have other appliances like what else? Okay, your sound system 70 watts. You're having 400 watts. So when you calculate all the load in your house, there is also a room that you have to give some percentage of space on your calculation. Okay, but when you calculate all this load in your house, if it's below 1000 watts, okay, you should know that your inverter will be able to power that load. But when you calculate all this load and the wattage has exceeded the capacity of your inverter, it means that the inverter is not going to be able to power it. If you try it, it can damage the inverter, or it's going to give you an error code. Okay, so that is all about this sizing of inverter, just for you to note all these things. So another thing you need to know that is that there is a way you can convert all these abbreviations. For example, 1 kVA is equals to 1000 VA. So when you are calculating VA, when you say, okay, you can have an inverter that is below 950 VA. Once it gets to 1000, it can be converted to 1 kVA. Okay, so once also 1 kVA, also 1000 kVA. When you count 1 kVA, 2 kVA, 3 kVA, 4 kVA, and it gets to 1000 kVA, it can be converted to megavolt ampere. So that is how you measure this. So if you can also do the same on wattage. Okay, once you have 1 kilowatt, okay, that means if the wattage from 900, 200, 100, 200, 300, 400, 500, if it gets to 1000, it can now be measured in kilowatts. Okay, if this kilowatt, 1 kilowatt, 2 kilowatt, 3 kilowatt, 4 kilowatt to 1000 kilowatt, it now cannot be measured, referred as megawatts. Okay, so this is how these measurements are. Now I want to show you how do you convert. Let's say for example you are given 1 kVA and say you should convert it to wattage. They are not the same measurement. There is always some conversion processes to it. Okay? So there is always a power factor that differentiates them. Okay, so the difference is due to power factor, usually about 0.8 in ohms. So if you are converting VA to wattage, you need to include this power factor, and this is the formula. So let's say you want to convert VA to wattage. Okay, so they gave you the measurement, let's say 1000 VA, and they say you should convert it to wattage. What you need to do, your wattage is going to be equals to the VA they gave you times this power factor 0.8. That is how you convert your VA to wattage. If you do that, you see that you have a more lower wattage. That means VA in terms of wattage, wattage is more higher than VA. Okay, so you can also do the same thing with in terms of VA. If you are given a wattage figure and say you should convert it to VA, which is a voltage ampere, what do? That wattage they gave you, divide it by this power factor, you'll be able to get your VA. Okay, these are simple calculations, okay, that you need to know. Note this power factor, because this is the only formula that can enable you calculate all these things very well. Okay, so this is how you convert VA to wattage and wattage to VA. All right, so this is basically about inverter measurement. So we are going to do more video. I'm going to be doing more video to explain to you how to size your inverter, how things to put into considerations and all that. But then this is what you need to know about inverter measurement, capacity and rating. Okay, so basically that is what I want to share with you on this video. I hope you have gotten an idea about what inverter is, the role of inverter, and the different types of inverter that you might likely come across there when dealing on solar system. Okay, basically that is it for this video. I hope you have learned 1 or 2 things from this video. So if you have questions regards to this video, use the comment section to ask. Okay, I'll be glad to attend to all your questions. Make sure you are locked in on our channel, because we are going to be publishing more content. We are going to be talking about batteries, we are going to be talking about charge controllers and other materials or components that are used in solar system. So make sure you are locked into the channel, subscribe, like and share this content with someone you know that will find it useful, and I will be grateful for that. Okay, I will see you in the next one.